All right, so today we are looking at, we want to learn about the constant of proportionality. They're really, that and unit rate are the same thing. So for example 1, I'd like for you to read it to yourself, pause the video, and then come back and we'll look at what you need to underline and circle. All right, so what do we need to underline? Well, I think it's important that they're concerned deer population might not be constant across the forest. And then we know there's 144 deer in 16 square miles, there's 117 deer in 13, and there's 216 deer in 24 square mile. Does it matter that the deer population is not constant? It does, and it could be things like if there's not a certain balance of deer, if it's not a constant balance, it could lead to losing a lot of the vegetation. And because the deer, if it's overpopulated in an area, it might clear out the vegetation and then they won't have a good ecosystem balance. There could be no deer in an area, and that might be because there's a wild animal that's eating them. Okay, so all of those kind of things, and there's probably other reasons. But this is a very good application of what a conservation officer might do. Okay, so the big thing here, we want to know if they need to be worried. And so we're going to do that by finding out the population of the deer per square mile. And we're going to look at this data. I'm going to look at it in a table. Okay, so when I draw my table, I'm going to start with, we know there's 144 deer in 16 square miles. So how about square miles is in the denominator, so that means that is the x if it's in the denominator. And so we're going to put square miles first. It doesn't really matter. Okay, and then we'll make the y the number of deer. So the number of deer depends on how many square miles you're looking at in the forest. And then we're going to look at y over x, which is the unit rate. All right, so in the number of square miles, we had 16 square miles, 144 deer. We had 117 deer in 13 square miles. We had 216 deer in 24 square miles, and we had, I think that's it. Okay, so then when we look at the unit rate, we're going to say 144y over x, 16, which would be equal to 9 if you divide that out. And then if we do 117 for 13 square miles, that's going to be 9 deer per square mile. And if we do 24, that box is kind of small, divided by, no, I'm sorry, I did that backwards. Let's get that right. Okay, so if I do 216 divided by 24, that's also going to be 9. So there's 9 deer per 1 square mile. All right, so the next thing, it says the unit rate of the deer per square mile, 1 square mile, is 9. This is called the constant of proportionality, or K. Okay, so we say that K is equal to 9. And we got that, we know that K, we got that by taking y divided by x. And we've looked at this equation before. Okay, so meaning of the constant of proportionality. K, in this problem, there are 9 deer for every 1 square mile. Okay, so then it says use the unit rate of deer per square mile to determine how many deer there are for every 207 square miles. All right, so what we could do, whoa, jumped out of my hand. Okay, we could come back to, there's 207 square miles, we could put that in a table. And then we could figure out, well, how many deer would that have to be in a 277 mile square radius? So, square area, not radius. Okay, so here we know that if we take the unit rate K, 9, or the constant of proportionality, if we multiply 9 times 16, we get 144. If we take 9 times 13, we get 117. If we take 9 times 24, we get 216. So instead of moving this table all the way down and counting out and, adding 9 every time, These aren't even in order anyway, but all we really have to do is multiply 207 by 9. So that means there'd be 1,867 deer. Okay, so again, we know that y is equal to kx, and we knew that our x was 207. So where is that? Okay, so the 207 square miles is our x. We know k is 9, so we can find y, which would be the number of deer. Okay, so deer, to determine how many deer, that's going to be our y. So we can say, if I take 9 times 207, that will give me my y, and that's going to be 1,867. So we can just use this equation. Y equals kx, or you can use k equals y divided by x to find the constant of proportionality. The k times the independent variable x will always give you your y, or your dependent variable. It says use the unit rate to determine the number of square miles in which you would find 486 deer. Okay, so this time we have 486, and we got to go back and find out how many deer. Well, if we know that that is y, let's look at our equation. Okay, so we have 486 deer. That's equal to, we know that's 9 is k. We don't know x, so we'll put y is equal to k times x. And then all we have to do then is solve this for x. So divide both sides by 9. So we've got x alone, so x would be equal to, on the calculator, let's see here, 54. So x would be equal to 54 square miles squared. Okay, so down here we've got some vocabulary, and I'm going to check while you read over your vocabulary, and I'm going to see how much time I have. I've got about halfway. So we're going to do another example. Our vocabulary, oops, if you look at it, let's get that back again. Okay, so a constant specifies a unique number, and k is going to be our constant here. A variable is a letter that represents a number. So our variables changed, okay, they varied, and then 9 was my constant all the way through. That's why it's called the constant of proportionality. All right, so you can go ahead and finish reading that. Let's go ahead and look at the next example. It says, Brandon came home from school and informed his mother that he had volunteered to make cookies for his entire grade level. He needed 3 cookies for each of the 96 students in the 7th grade. Unfortunately, he needed the cookies for an event at school on the very next day. Brandon and his mother determined that they can fit 36 cookies on 2 cookie sheets. Is the number of cookies proportional to the number of sheets used in baking? Create a table that shows data for the number of sheets needed for the total number of cookies. Okay, so instead of starting out with 2 and 36 here, I'm going to put 2 here, and I'll put, let's see which one, how do we want to do that? I guess we're going to do it this way. So 2 trays, how many, or sheets, I guess. Number of sheets, cookie sheets, is what I'm going to put there, and the number of cookies is going to be 36. Okay, so is it proportional? So let's go, let's say, well, if I had 1 sheet, how many cookies would that be? Well, if you divide that by 2, you get 1. If you divide that by 2, you get 18 cookies. That's pretty easy to see. I hope you can see that. Now, if we look at our unit rate, or let's now call it K, the constant of proportionality, to get from here up to here, we want to know how many cookies per sheet. Okay, so we're getting number of cookies per sheet. So we know if it's number of cookies, look at that over here, cookies per sheet, then cookies will be the Y and sheets will be the X. So we are doing Y over X. So we did 36 divided by 2, and we got 18. That's how many 18 cookies per 1 sheet. All right, so if we then go on down, we know our constant of proportionality is 18. So if we do 3 cookies, well, we could add 18 here, or we could just multiply 3 times 18 to get 54. And then if we had 4, we could multiply it by 18 and come up with 40 and 32 is 72, I think. Okay, so it's, let's see, yeah. Okay, so we're doing 18 divided by 1. Those are all y over x. But we could also say, well, if I've got my x and I multiply it times my k, y over x equals k, but if we know k, we can multiply x times k and find y, or y equals k times x. That's the same thing. So our x's, we're just multiplying them by 18. Here we're taking 4 times 18, and that's where we got y would equal 72. 2 times 18, 36. 1 times 18, 18. So the unit rate is 18. The constant of proportionality is 18. Okay, so the meaning of constant of proportionality in this problem is 18 cookies per sheet. Okay, it took 2 hours to bake 8 sheets of cookies. If Brandon and his mother begin baking at 4 p.m., when will they finish baking the cookies? Let's see how much time we have left. I've got about 3.5 minutes, so we should be able to do this. So if it took 2 hours to bake 8 sheets of cookies, that means it's going to be 8 sheets per 2 hours. Okay, and his mother began baking at 4 p.m. When will they finish baking the cookies? Okay, how many? They can do 8 sheets. And we got to go back up here then and see. He needed 3 cookies for each of the 96 students. So we're going to say then he had 96 times 3. So that's going to be 288. So he has to make 288 cookies. And we know that we can get 18 on a sheet. So 288 divided by 18 is, let's see, I should be doing this on a calculator. Let's see if I have that. These how many sheets? So that'll be 16. Okay, so we need 16 sheets. Okay, and they're going to do 2 hours to bake 8 sheets. Okay, so if it takes 2 hours to bake 8 sheets, we can go hours to sheets. So how many sheets per hour really? So it's going to be 8 sheets in 2 hours, and we need 16 sheets. So if we do 8 sheets in 2 hours, the constant of proportionality is 4. It's K. And so if we've got, where were we again? Let's see, we've got 16 sheets, so we'll put 16 here. We need to know what times, or 4 times what gives me 16. But I could also then say, well, I can just take 16 and divide it by that constant of proportionality and go back and find out that it's 4. Because 4, the K, times this 4 would be 16. So it's going to be 4 hours. So if they begin baking at 4 p.m., when will they finish baking the cookies? Well, in 4 hours. So 4 hours from 4 p.m., they would finish baking at 8 p.m. Okay, that's all we're going to have time for. Let me see what the time is. Okay, so what I would like for you to do, we've got a French class cooking. You can try to do that one on your own, and we'll talk about it when you come in. And then we'll do the exit slip, and then you can start on your practice tomorrow in class. Have a good day.